Hi students, welcome to today's class. Today I am going to explain examining differentiability using differentiation and graph of the function. Using differentiation, how to check? So previously given a function, if you want to check the differentiability of the function at a point x is equal to some a, so we checked at x is equal to a, left hand side derivative, right hand side derivative. So we applied the formulas. So LHD, RHD formulas we applied, and if the LHD is equal to RHD, then we declare that the function is differentiable at that point. Of course, that should be continuous. Previously we have to check it continuously. So without using those formulas, LHD and RHD, all those formulas, directly by using differentiation, how to find out the given function is differentiable at x is equal to given point. Let us see the question. F of x is equal to cos of mod x. F of x is equal to cos of mod x at x is equal to 0. So we have to check the differentiability of this function at x is equal to 0. Okay, now let us check it here. So to do this, no need to first check, actually it is a continuous at x is equal to 0 cos of mod x graph. So no need to use LHD and RHD, no need to use. Okay, now so how to do this? So when x is equal to 0, so this modulus of x function will change its behavior when x less than 0 and x greater than 0. So let us redefine this function like this. So f of x is equal to, when x greater than 0, when x less than 0, let us see what happens. When x greater than 0, x less than. If x greater than 0, mod x is equal to how much? X. Therefore, we will get cos x. When x is less than 0, modulus of x is equal to how much? Minus x. So cos of minus x, again we are getting cos x. Again we are getting cos x. So therefore, what is f dash of x is equal to cos x derivative minus sin x. When x greater than 0, here cos x derivative minus sin x when x greater than 0. So what is f dash of 0? At 0 we are checking. What is f dash of 0? Minus f dash of 0 plus right hand side derivative minus sin 0, that is equal to 0. So f dash of 0 minus sin 0, that is equal to 0. So right hand side derivative, left hand side derivative, both are equal. Therefore, this is a differentiable at x is equal to 0. So here we did not use any that LHD, RHD formula. Given a function, differentiate it and substitute whatever may be the value in the LHD and RHD, both values are same. Therefore, it is differentiable. It is a very simple method. So let us see that also. Let us see here. So let us redefine this function. Let us redefine this. If x is greater than 0. If x is greater than 0, mod x is equal to how much? X. So therefore, x by 1 plus x. If it is x less than 0, if it is x less than 0, x by 1 minus x. Mod x value, x less than 0, mod x value minus x. So let us take this f of x. Now let us define f dash of x. F dash of x. What is f dash of x? Okay, now f dash of x means what? X by 1 plus x. Okay, u by v formula. U by v formula, that is 1 plus x into x derivative 1 minus x into x derivative 1. This is 1 by 1 plus x whole square. So here plus x minus x cancels, 1 by 1 plus x whole square when x greater than 0. Okay, now when x less than 0, so what is the derivative of x by 1 minus x? So here you will get minus x, 1 minus x minus of x into 1 minus x derivative minus 1. So this is a plus 1, both will get cancelled. So you will get 1 by 1 minus x, x square, x less than 0. Okay, now find out f dash of 0, f dash of 0, 0 plus this x greater than 0. Substitute here 0. 1 plus 0, 1, 1 square by 1 is equal to 1. So find out f dash of 0 minus, so this is how much? X plus 0, 1 minus 0, 1, 1 minus 1, 1. So for right hand side derivative, left hand side derivative, both are equal. Therefore, this function is differentiable at x is equal to 0. Observe here, even though here modulus function is there, it does not affect the differentiability of the function at x is equal to 0. From these two examples, what is the thing you observed here? What is the thing, what is the point you catch? So the thing is, so given a function, redefine the function, find the left hand side derivative, find the derivative of that function, So substitute like this. If it is both values are 0, then it is differentiable. If they are not equal, it is not differentiable. Okay now, so I hope that you understand this concept. Let us do some problems based on this graph, based on this concept. Okay. Welcome to this problem. If f of x is a function, it is defined as like this: x less than or equal to 1. 1 and less than 1, the function is defined as x. If x is greater than 1, that means 2, 3, 4, like not 1. Greater than 1 means what? More than 1. So x square plus bx plus c is greater than. Then is asked to find out the values of this b and c, that is x coefficient and constant. If f of x is differentiable, it is given that f of x is differentiable at x is equal to 1. So always remember, it is differentiable at x is equal to 1 means what? It is continuous. First of all, it continuous at x is equal to 1 also. So let us see this problem. So here already f of x is given. Let us find out the derivative. So f dash of x is equal to 1 when x less than 1, 2x plus b, x greater than 1. Okay now, first of all, continuous. Continuous means what? At x is equal to 1, continuous means what? LHL is equal to RHL. Left hand side limit is equal to right hand side limit at x is equal to 1. So what is that limit? X tends to 1 minus 1 is equal to limit x tends to 1 plus, this is a 2x plus b, 2x plus b. X tends to 1 means this 1 only. So this is equal to, sorry, so it is absolutely wrong. So we have to substitute here. So here x less than 1 means, so this is equal to x. So this is equal to 2x x square plus bx plus c. In this value you have to substitute, not in the derivative you have to substitute. Okay, first of all, this is a continuous at x is equal to 1 means what? LHL is equal to RHS. Limit x tends to 1 minus means what? X less than 1. The function is defined as 1. X greater than 1, right hand side limit is this. So x is equal to 1, substitute here 1 plus b plus c. X is equal to 1. So here b plus c is equal to 0. Okay now. So again, this is, we used the concept continuous. Let us use the differentiable. Differentiable means what? F dash of 1 minus is same as f dash of 1. So left hand side derivative is same as right hand side derivative. What is the left hand side derivative? 1. What is right hand side derivative? 2x plus b. That means 2 into 1 plus b. 2x plus b means 2 into 1 plus b. X is equal to 1. So here b is equal to how much? Minus 1. So b is equal to minus 1. Substitute here c is equal to 1. Understand? So b is equal to minus 1, c is equal to 1. These are the two values. Okay, we have. So very easy problem. So here we used the continuity concept and we used the differentiability concept. We got the answer B and C. So this type of problems also will be asking in the JEE mains examination. Okay now. So I hope that you understand this solution. Let us see one more problem. Welcome to this problem. Find the values of a and b if f of x, it is a function defined as like this: x greater than or equal to 1, the function is defined as a plus sine inverse of x plus b. If x less than 1, the function is defined as x, then is differentiable at x is equal to 1. So first we will make use of the concept continuity. Okay, since he is saying differentiable at x is equal to 1, previously the function should be continuous at x is equal to 1, then only it will be differentiable. Differentiable means what? So if you are able to draw a unique tangent at that point, then we say that the function is differentiable at that point. Okay now. So let us see the solution. First to find out the derivative of that function. So what is the derivative of the function? F dash of x is equal to, the derivative of a is 0. Okay na? So why? Because it is a constant. The derivative of sine inverse of x plus b is 1 by root of 1 minus x square, that is x plus b whole square, if x greater than 1, for x derivative 1 where x less than 1. Understand this. So first we will use the continuity concept. That means what? F of 1 plus is same as f of 1 minus, that is a left hand side, right hand side, RHL is equal to LHL. Now you substitute there. So in this you substitute here. So A is A only, A plus sine inverse of 1 plus B. In place of x we have substituted A plus sine inverse of 1 plus B is equal to 1. Call it as first equation. This is what continuity concept we apply. Now differentiability. LHD is equal, that means what? F dash of 1 plus is same as f dash of 1 minus. So right hand side derivative is equal to left hand side derivative. So wherever x is there, substitute here. Wherever x is there, substitute 1. So what? What you will get? 1 by root of 1 plus b whole square is equal to f dash of minus 1 is equal to how much? 1. Okay now. So from this without doing, just by guess we can say that b is equal to 0. B is equal to, if we put b is equal to 0, 1 plus 0 1, 1 square 1. So not b is equal to 0, b is equal to minus 1, sorry, b is equal to minus 1. So if you substitute b is equal to minus 1, substitute here 1 minus 1, 0, 0 square 0, 1 minus 0 1. So this is equal to, you will get. So b value is minus 1. So substitute b value minus 1 here. So if you substitute b value minus 1, 1 minus 1, 0, sine inverse of 0, 0. So a is equal to 1, you are getting. A is equal to 1 is the answer. So a is equal to 1, b is equal to minus 1 are the right answers. So here we applied the continuity concept. Here we applied the differentiability concept. Like that we can find out a value and b value. So if this type of problems are given, so if you start these solutions like that, the problem will be very easy. Okay, so let us see one more problem. Welcome to this graph problem. Draw the graph of f of x is equal to sine of mod x and discuss the differentiability. So we have to draw the graph of f of x is equal to sine of mod x. So you may ask one thing. So in the JEE mains this type of problems will come, sir. Yes, it will come, definitely it will come. So here using some graph we can easily guess the either differentiable and non-differentiable, where it is differentiable, where it is non-differentiable. Okay, using graphs, our title is also graph of the function. So how to draw the graph of f of x is equal to sine of mod x? First to draw the graph of sine x. First to draw the graph of sine x. Now I will show you. So how to draw the graph of sine x? See here. So this is equal to x axis and it is a y axis. So here 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2. So these are negative angles, minus pi by 2, minus pi, minus 3 pi by 2, minus 3 pi by 2, and it is a minus 2 pi. So like that. So this is equal to 1 and it is minus 1. So sine 0, 0, sine pi by 2, 1, sine pi 0, sine 3 pi by 2, minus 2 by, it will go on. So this side minus 1 and again sine minus pi 0, sine 3 pi by 2, 1. So this is the graph of y is equal to sine x. Everybody knows y is equal to sine x. Okay now. Then what is the graph of sine of mod x? What is the graph of sine of mod x means here to the left of x, if it is a x greater than 0, sine x is equal to sine x only. That means from this side you will get the same graph. If x greater than 0, sine x is sine x only. If x is less than 0, modulus of x is equal to how much? Sine x. Minus sine x you will get. So y is equal to minus sine x when x less than 0. From this side you have to draw the y is equal to minus sine x graph. So that is nothing but just image of this graph. Image of this graph. What is the image of this graph? Means this. What is the image of this? So this is the image. What is the image of this area place? This is the graph. So just you avoid this. Understand this? Okay now, right. So this is the graph of y is equal to mod x graph. Y is equal to mod x. Okay now. So you clearly, so where it is a non-differentiable. So if you observe here, see here, is there any sharp edge here? So come again, it is coming sharp here. At x is equal to 0, y is equal to sine of mod x is having a sharp edge at x is equal to 0. Therefore, at x is equal to 0, it is non-differentiable. Non-differentiable. At x is equal to 0, the function is non-differentiable. Understand this? So by drawing the graph, you can see. But theoretically, then how to do this theoretically? Okay. So it is a what graphically we explained. It theoretically how to draw this. But let us see that. So let us see this actually practically we explain this. Let us see theoretically. So see our given function is f of x is equal to, if x greater than 0, x less than 0, greater than or equal to 0. So this is equal to sin x, this is a minus sin x. Okay now, if x greater than or equal to 0, f of x is equal to sin x, y modulus of x is x. Right. So f dash of x is equal to sin x derivative cos x, if x greater than 0, minus cos x if x less than 0. Understand? So at x is equal to 0, check here at x is equal to 0, f dash of 0 plus and f dash of 0 minus. Let us check here at x is equal to 0. So x greater than 0, cos 0, 1. At x less than 0, cos 0, 1, minus 1, minus 1. What we are observing here? Both are not equal. Therefore, at x is equal to 0, f the function is non-differentiable. This is theoretical. So previously, using the graph, we explained it. So at x is equal to 0, there is a sharp edge you are getting. So therefore, at that x is equal to 0, you cannot draw a graph. So you cannot draw a tangent. Understand this? That is a graphical and it is practical, theoretical. Understand this? So I hope that you understand this theoretically. So based on this, so you first if you want to develop this subject knowledge, first to solve this small problem. So understand the concept, then you go for very big problem. Okay now. So let us see one more problem. Welcome to this problem. So f of x is equal to minimum of x comma sin x. So f of x is equal to minimum of x comma sin x. Let us take the minimum value. So how to, first of all, you have to write it in a function format. Okay. So to write this, we have to draw the graph of y is equal to x and y is equal to sin x. Draw the graph of y is equal to x and y is equal to sin x graphs. Then how to define, convert this into function form. So this is a x-axis and it is y-axis and it is a 0. This is a pi by 2 and it is a pi. This is a 3 pi by 2 and it is a 2 pi. And this side minus pi by 2 and it is a minus pi. This is a minus 3 pi by 2 and this side minus 2 pi. Okay now. So this is a plus 1 and it is minus 1. Okay, sin 0 is 0, sin pi by 2 is 1, sin pi is this, again this and again this. And this is a graph of, everybody knows that graph. Okay now. Now this point is over, graph of this y is equal to sin x is over. Now what is the graph of y is equal to x? So y is equal to x is a graph passing through the origin and it is like this. It will be like this graph. Understand this? The graph will be like this. So this is a y is equal to x graph. Y is equal to x is a straight line. See here, now the function is defined like this. f of x is equal to when x less than or equal to 0 and x greater than 0. When x less than or equal to 0, see the graph here from x less than or equal to 0, graph is which is the minimum, either sine curve or line y is equal to x, either y is equal to sin x or y is equal to x, y is equal to x, therefore it is x. If x greater than 0, x greater than 0 means what? To the right of. See here, which is a minimum, y is equal to x or y is equal to sin x, which is a minimum, y is equal to sin x. So this is the graph of the, so this problem is converted into in this format, understand? So in examinations, sometimes it will, if it is given like this, everybody can do. If it is given like this, minimum of, maximum of, then we have to draw the graph and we have to take the inference from the graph. Okay now, so let us do this problem differentiation you do. So what is the f dash of x is equal to 1 if x less than 0, cos x x greater than 0. Okay now, at x is equal to 0, find out left hand side derivative, right hand f dash of 0 minus f dash of 0 plus. F dash of 0 minus is what? 1. Okay, so f dash of 0 plus means x greater than 0, cos 0 value is equal to how much? 1. So left hand side derivative, right hand side derivative, both are same, and therefore the function is differentiable at x is equal to 0. So we have a small doubt here. At x is equal to 0, so we have a, for both the curves we have a tangent. We have a tangent at x is equal to 0, we can talk. Okay, so I hope that you understand this is today's concept and problems. Let us see tomorrow.